Okay, I just wanted to go over the solutions to today's test, which was Business Calculus Test 3. So your first problem asks you to do the indefinite integral of x squared minus 2x cubed plus 1 dx. And to do this problem, you need to use your antiderivative power rule, which says that x to the power of k, its antiderivative is x to the power of k plus 1 divided by k plus 1. So if we apply that to each term, the antiderivative of x squared is x cubed over 3. The antiderivative of minus 2x cubed would be minus 2x to the fourth divided by 4. And the antiderivative of plus 1 would be x. And then for all indefinite integrals, you always add the plus c term. If we simplify this, we get that this is equal to x cubed over 3 minus x to the fourth over 2 plus x plus c. And we get the x to the fourth over 2, of course, because 2 divided by 4 leaves a 2 in the denominator. In your second problem, you had to integrate 5x to the fourth times e to the power of x to the fifth power dx. This requires a u substitution, so we let u be equal to x to the fifth power, and then du becomes 5x to the fourth dx. If we do this, we substitute u as x to the fifth power, and we have left 5x to the fourth dx, which is exactly our du. Our integral now becomes the integral of e to the u du. The antiderivative of e to the u is equal to e to the u plus a constant. And when we substitute x to the fifth power in for u, our final answer is e raised to the power of x to the fifth power plus the constant. Our third integral is a definite integral because it has limits, so it's the integral from 1 to 2 of the natural log of x divided by x dx. We will again need a u substitution. So let u equal the natural log of x, and du will be equal to 1 over x dx. Substituting in and first solving for the indefinite integral, we get the integral of u du as u squared over 2 plus a constant. Substituting in for u, we get that's equal to the natural log of x, all squared, divided by 2, plus a constant. But remember, we do have a definite integral here, so we're going to apply the fundamental theorem of calculus to solve the definite integral. When we do, we will evaluate the antiderivative at the upper limit and subtract what we get when we evaluate it at the lower limit. Notice that we do have a common factor of 1/2, so that's factored out. And in brackets, we evaluate our antiderivative, the natural log of x, at 2, so we get the natural log of 2 squared, minus the antiderivative evaluated at 1, which is the natural log of 1, all squared. If we recall that the natural log of 1 is equal to 0, our final answer is the natural log of 2, all squared, divided by 2. Now in your final question, I did make an error, and so for that I'm going to give everyone the 5 bonus points. It read, an office supply company sells X mechanical pencils per year at P dollars per pencil. The revenue generated by pencil sales is given by the revenue function R of X is equal to 10 minus 0.01x squared, where X is between 0 and 100. In the problem on the test, I had that as X is between 0 and 1000 as a typo. So you will be unable to answer the extra credit question properly because of that mistake. I'm going to give everybody the points again, as I said. So you're asked to find the number of pencils that need to be sold to maximize the revenue. So this is a problem in which we have to maximize the revenue. So that means we need to take the derivative and find the critical values. So we have R of X is equal to 10 minus 0.01x squared. The derivative of that is minus 0.02x. Setting that equal to 0, we see that x is equal to 0 is the only critical value. And so the max is at 0 or 100 because we had a closed interval 0 to 100. And we know from the extreme value theorem that we must attain a maximum and a minimum on the closed interval, which will occur at the endpoints or any critical values. R of 0 is equal to $10. So if you plug 0 into that function, you get 10. And R of 100 is equal to $0. And therefore, for this company, revenue is max when no pencils are produced. So it's a silly company that I've made up, but I wanted to make the problem straightforward for you. And so in this particular case, the maximum occurs at 0, and that maximum is $10.